Good morning, everyone. I'm Professor John Nguyen. Welcome to Chemistry. Today, in this discussion, I would like to show you how atoms are connected using valence electron, and we call them loose structures. And you can see the definition there. Loose structure are structural formulas showing atoms connected together via chemical bonds. Okay, it's always good to know what we need. First, we need the number of valence electron for each atoms, and you can figure that out by using electron configurations. For example, carbon has total of 6 electrons, and the electron configuration is 1s2, 2s2, 2p2. So if you look at the highest shell number 2, you will see there's 2s2 and 2p2, so you add up, that will be 4 valence electron. You can also look at the periodic table for group 1, such as hydrogens, we have 1 valence electron. Group 2, which is the column 2 on the left, the second column on the left of the periodic table, 2 valence electron. And then let's skip the 3 to 12, the transition metals for now. Move on to 14. You notice carbon is on group 14, drop to 10, so we have 4 valence electron. And you go from there. Group 15, nitrogens, 5 valence electron, oxygen, 6 valence electron, so on and so forth. Okay? So that's the first one we need to know. These are the foundation concept. Second, we need to know another thing is that each valence electron uh, is represented by a dot. And a bond, a single bond, is simply a line connecting two dots, which means two valence electrons together. Okay, so those are the basic concept. Now the third thing is the octet rule. Octet means 8, okay, surrounding an atom. So Lewis said that, proposed that theory that if an atom has octet configurations surrounded by 8 electrons, we are talking about valence electron, they are stable. Okay, so the octet can be any combination of bonds and electron lone pairs. For example, if carbon has 4 bonds, remember each single bond is composed of 2 electrons. So 4 single bonds equal to 8 electrons. That's octet. Okay. Now we can have another combinations. It doesn't have to be carbon. Any atoms, for example, nitrogen has 3 bonds and 1 pair of electron. Okay, that 3 bonds that's equal to 6 electron plus a pair that's 2 electron. So the total of 8. So that's also octet. All right. Now, and here's the rule. The only rule is that atoms in the first and the second row or periods must obey octet. So no more than 8. It can have less than 8. It can have 6, 7, 5, whatever. But 8, but no more than 8, no 9. Okay, so nitrogens in the second row cannot have more than 8 electrons. Okay, so those are the rules. Those are the requirements. Now let's start with the first one, CH4, simplest one, right? Okay, we need to know Lewis valence electron. Carbon has 4 valence electrons. So we want to put 4 dots in 4 corners. We don't want 2 pairs. We don't want 1 pair and 2 single either. Okay, we want to maximize the single electron, the unpaired electron. We want to maximize the bonding capacity because the bonding can start out with single electron or unpaired electron. Okay, now surrounded with 4 hydrogens and it's obvious, usually common sense. Carbon is in the center and surrounded by four hydrogens. Obviously, because hydrogen has only one valence electron, cannot be in the center, can only form one bond. So if you connect the single electron together or the unpaired electron together, you got four single bonds. That's it for CH4. That's called Lewis structure for CH4. Good, everyone? Okay, move on to the very popular molecules. Water, okay? Water has one oxygen. So it makes sense to put oxygen in the center, two hydrogens, okay? Now it is very important to know how to label valence electron correctly, okay? Let's say you start out on the top corner. Doesn't matter which way you go. You go clockwise, 1, 2, 3, 4, and then you start the second round in that sequence. Please don't change the sequence. Okay, we don't want to jump around. Okay, we want to keep that sequence. So that's where you end up with two pairs and two unpaired electrons. Okay, now when you put the hydrogens in, each hydrogen has a single or unpaired electron. You line them up next to the unpaired electron of the oxygens. Okay, and then simply connect them. You got water molecules. Now notice that you got two bonds in series, in sequence, close together, and you got two lone pairs of electrons on this side. You can change them as long as they close by. Okay, you can change them to be on the left side, lower left side if you want to, but don't put one on top, one on the bottom, and then bond on left and right. That looks pretty symmetrical, but that's not the actual shape of the water molecules. Okay, so if you do it right, it make it a lot easier for you to make that judgment, make that uh, prediction of what the molecular geometry of a molecule is. Okay, all right, we'll go over more example of uh, Lewis structure of neutral molecules and also ions in the next short video. Thank you, everyone. See you guys soon.